Okay, so this is an exponential decay. First, we note that after 2 hours, the activity of y has dropped from 1000 to 900. So it has dropped 10%. So what we have here is 90% of the initial activity. This is an exponential decay. This means that for the same duration of time, the fractional drop is the same. So if in 2 hours it has dropped 50%, then in another 2 hours, the activity is going to drop to 90% of what was here. So the activity here will be 90% times 90% of the initial activity. So if you are talking about after 8 hours, then when it's at the 6 hour mark, it will have dropped to 90% times 90% times 90%. When it's at the 8 hour mark, the activity will have dropped to 90% to the power of 4 of A naught. Alright, so after every 2 hours, you drop to 90% of what it was 2 hours before. This is the nature of exponential decay. What about x? For x, we realize that after 4 hours, it has dropped to 90% of the initial activity. So 4 hours drop to 90%, right? So you must give it another 4 hours before it drops to 90% times 90% of the initial activity. So if since the question asks for the activity of x to the activity of y after 8 hours, so for x, the activity will be 90% square of the original, whereas for y, it will be 90% to the power of 4 of the initial activity. So that will give us the answer. It's actually 1 divided by 0.9 to the power of 2, which will give you 100 over 81. Okay? So the key idea is, given the same duration of time, it will fall by the same fraction. That is the nature of exponential decay.